Good evening, guys. Good evening. Good evening. How are you all? Good evening, Prajwal. So I was a little caught up with work, so I was. That's the reason why I had to delay it 15 minutes. But yeah, we'll keep the session 1 hour itself, so we'll not run short on anything today. So the recording for day 5 and today will be uploaded together. Okay, and the rest of the part will be considered as your assignment. So I think everybody has submitted their assignment. People have not joined yet, so I'll just wait for some time for people to join. The meanwhile, I'll just check if everybody has submitted your assignment. Just go to the drive. Um, okay, I think everybody has submitted. Yeah, and from today onwards, your attendance also will be counted, right? So the first few days we took it very leniently because you know due to the scheme change and everything, we had to make sure that some people did not know, so just giving the attendance to everybody. But yeah, from today onwards, your your attendance will be monitored and it will be updated on a regular basis. Okay, so that is one thing I wanted to tell you. And yeah, I think today not many students have joined so far. We'll still wait for another 2 to 3 minutes and we begin. Only 14 students so far. Okay, let's wait for 6, 7 students more. Let's make it more than 20 and then we'll begin. Good evening to the students who've joined just now. Good evening. Okay, I think we have enough number of people now. So as I mentioned that I'll not be letting students after 15 minutes since the classes began. So make sure that whatever desired time I'm telling you to join, make sure you're present in that time. Okay, so that we don't have to stop the class in between and it will cause a lot of disturbance. So as a result, I want everybody to make sure that you are here at least 5 minutes prior to the class. Even if you don't start, it's fine. Just be here 5 minutes prior, then we can begin the session. Okay, so I think we have good enough number of students here. So what I'll do is I'll mute my browser volume because the notifications of Google Meet would come if somebody joins. But yeah, Anyway, so let's begin today's session, and I hope all of you understood till the part where we have studied about featureization, basically feature scaling, right? And we will also see basically how to prepare the data set for a particular model that we're trying to build. Okay, so today we will walk through the entire theory that we have done so far. Okay, what have we done so far? So far we have studied the entire workflow, right? And out of that entire workflow we have studied certain things that need to be present in a ML model or an ML workflow, right, as a whole. So what is the first thing that we do? We always collect the data set, right? So for now, let's not waste time collecting the data set. I've already done that. Okay, and it is a data set which is very famously used for for understanding beginner level models and how to actually play around with data and how to figure out a lot of things related to data. Okay, so I will just make sure I share that screen so that you guys can have a look at it, and let me make sure I've started my recording also. um, yeah, are you guys able to see my window? I mean, are you able to see my screen? I think you can see my collab screen. I don't think you're able to see my data set. Are you able to see the data set, guys? No, right? Okay, just give me a moment. Let's give me a moment. Just give me a moment. Okay. What about now? Are you able to see my data set screen? No, I don't think so again. Okay, let me just do one thing. Let me reshare it. I don't know why it's not. Yeah. Now, are you able to see my data set? Just say yes or no. Yes. Okay. Fine. 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 All right. Yeah. So this is the data set that we will be working on. And before we understand what exactly we are trying to do, we will first understand what is the entire goal of our, today's module, today's session. Okay. So first thing is that let's come to a problem statement that we need to identify. So now the question begins with, how do we actually uh, try to understand what we want to do in a particular data set. Now, let's say I hand you out this data set. Just check if yes, okay. So let's say I handed you out this data set, okay, without any goal. What will be your first thinking be if you see the data set? Yes. What will be your first thinking about the data set? Let me just capture. Yes. What will be your first thinking about the dataset when you see it? Yes. What will be your first thinking about the dataset? Yes. Yeah. Tell me, guys. What will be your first thinking about the dataset if I just give you over, a file like this? If I give you a CSV file like this, what is your thinking going to be? Yes. What are you going to think? Okay. Nitish's features of the dataset. What about others? Yeah. What about others? Okay, features of the dataset, fine. So there are some features over here, right? We have something called as fixed acidity, volatile acidity, citric acid, right? Then what else do we have? We have residual sugar, we have chlorides, we have free sulfur dioxide, total sulfur dioxide, density, pH, sulfate, alcohol, quality. Right now, looking at these feature also, like how are you able to identify what your actual goal is? Yes, the output will predict. Correct, that is right, Nitish, because that is our end goal, right? Our end goal is to make a prediction or make a decision based on the features, right? But now here, just by looking at the data set, will you be able to identify what you have to predict? Yes or no? My question is very simple. If you're looking at this data set, if I just give you this data set, what are you going to do with this data set is my question. So first thing is you need to have a goal in mind, correct? So your goal, okay, does not come from the numbers that you have in the data set. No, this data set will be created after you have a goal in mind. Do you understand this? Yes. So the first thing is you need to have a goal. Once you have a goal, then you will come to a conclusion that okay, this is the data set that I need to find out. Okay, now if you don't have a goal in mind, you will just pick a random data set and then what? Then what are you going to do after that? Nothing, right? You can't do anything with that. Now, if I give you this data set, do you know what the goal is? Do you know what you're trying to predict? Maybe this is just a data, just like a sample data that I try to show you, right? Could be anything. So the first thing is we need to identify the correct goal for this entire data set. Now I'll tell you the context behind this data set so that we can understand what exactly are we trying to do here. Okay, so the basic thing when you look at this data set is that we are trying to identify the best quality, or we're trying to classify the normal quality or the excellent quality with the poor quality ones. Now you can see some numbers here, right? You will see 5, 6, 7. um, oh yeah, you have 7, and then I think you have yeah, you have 5, 6, 7, 5, 6, 7, 5, 6, 7. Yes. So based on these numbers, okay, you are trying to predict what kind of quality is your data, I mean, is your wine having, whether the wine is of excellent quality or whether the wine is of poor quality. So this entire data set is a wine based data set. So all of this data that you can see on the screen is nothing but related to a wine, quality of wine. Okay, and the quality of wine is nothing but based on different factors. Now these different factors are acidity, volatile acidity, citric acid, residual sugar, chlorides, sulfur dioxide, total sulfur dioxide, density, right? So all of these are nothing but features of, guys, please mute yourself. Okay, just yeah. So so the thing is that these are all the different features of your wine dataset. Okay, so based on all of these features, you will be able to identify whether the quality of the wine is good or bad, or is it excellent or is it poor. Okay, so we are trying to build a regression model to make sure we predict the quality of the wine based on the factors that we have. So now we have a goal in mind. Yes, what is the goal in mind? We are trying to build a regression model which allows us to predict an outcome. Okay, so now since we haven't gone into the the theoretical part or the explanation of different types of ML algorithms, we will not stick to that. We will stick to the database, I mean the data set part. Okay, so for this data set, we are going to do the basic data pre-processing, basic data inspection, featureization, and feature selection. So we will see one by one how to do all of that using our Colab notebook. Okay, so is this clear? Do you now understand what exactly do you mean by how to select the data set? How do you select a data set? How do you build a data set, right? Based on, obviously, it is going to be based on your what? Based on your understanding about the data set, correct? So that is the reason why we have to first have a goal in mind, and then we can proceed with the data creation or data selection part. Okay, so now let's move to Colab. And those who don't know what Colab is nothing but a coding environment, which is introduced by Google, which was introduced by Google, and they have an entire processing unit. They have free RAM and disk storage, which you can use definitely, and they have different runtimes also. So if you want to run deep learning models, you can use T4 GPU. If you want to run heavier models, you can use TPU. And if you're just using normal models, or if you're just running basic processing models, you can just go for the CPU. And that is what exactly we are going to use. We're not going to use any kind of GPU because we don't have any kind of heavy rendering over here, right? We're not using any heavy models like image processing or speech recognition. So when we do all of that, when we see all of that, that is when we will proceed further with all of that. Okay, so first thing is we will try to import the dataset into our Colab environment. So if you just have a look here, you will see the files area, okay, the files icon. If you click on this, you will see an upload button, and simply you can upload that particular CSV file into your file explorer. So it is loading here, and yes, now it has been uploaded into our file system. So this is what we will be using in order to get the data from the CSV. Now let's try and have a place where we define the goal, so that whenever you look at this notebook, and try to think that, okay, why is this happening, why is that happening, you will be able to read all of this, whatever I've written, so that you will understand, okay, what exactly we are trying to do. Okay, so our objective is what? Objective to create an ML model. Let's not call it a regression model, let's call it an ML model for now. When we discuss about all the types of machine learning and all of that, then we will go on towards learning all of that and then implementing that. Okay, so to create an ML model, using what? Using a wine data set, where we use the features of the data based on different wines and predict the final quality of the wine to differentiate between what? Between excellent or poor quality ones. Done. This is the objective. Now let's begin with the first initial step. Okay, so what is the first initial step? Data loading part. So here we are not doing collection, guys. Remember, keep in mind, we're not doing data collection because data has already been collected, right? So if you're proceeding with the data collection part, it is a very huge process, because data collection requires a lot of subject knowledge, and we will see all of that. Obviously we cannot implement that in practical, because that will be something that you will implement in your project, right, when we try to do that. But obviously we will discuss the entire data collection part, how we collect the data, how actually we try to clean the data and stuff. Okay, so right now, since this is just the initial stage of our practical sessions, and we're just trying to get into how to load the data, pre-process the data, we will only have a look at how exactly we are loading the data, and we are pre-processing and whatever featureization, scaling, and data modeling. We are going to see all of that. Okay, so the first thing is we are going to load the data set. Now before we load the data set, obviously we need to import some kind of libraries. Right now these libraries are very important. Why? It is because we have to make sure that everything that we do is based on the libraries of Python that we're using, because we're using Python, and Python has a lot of different inbuilt libraries, which makes us us easier makes it easier for us to apply any kind of pre-processing functions or operations. So first thing is we need to import our two main libraries, which is NumPy and obviously import Pandas, right? Pandas as PD. So usually people use NP and PD, and I also prefer using NPPD. But if you prefer just writing a single variable like n or p for Pandas, so you can also do that. There's no objection on that. So these are the two libraries that we'll be using. So moving down further, obviously when we do our data visualization part, when we build our ML models, we will see more number of libraries coming into picture, and we will see how exactly those libraries work. Okay, yes, so we will start with the data loading part. So how do we load the data? So first thing is we write a data frame variable, because we want to convert this entire CSV file into a data set, into a data frame. So here you can see it is already auto completing it. So you can see pd.read csv wine. I think the file name is, yeah, file name is also right. So it is wine quality red. So it is basically based on red wine. So how red wines have different features, and that will be having different quality of wine. So maybe poor quality, maybe an excellent quality of wine. Okay, so based on that, we are going to read the CSV and we are going to uh, convert it into a data frame. Now, one thing you can do is for industrial practices. Okay, this is for industrial practices. This is not necessary for your mini projects or anything. But when you're working in an industrial level project, then definitely you can add this kind of logic where you will write the try block and you will try to read the file, and you will just print that the data has been loaded successfully. It's been loaded successfully. Okay, now what about when we want to basically not just read the data set, but also have a condition where we are able to throw an error if the file is not present. So what you can do, you can always write the except block, and here you will write the file not found error. So this error usually helps us to throw an error if the file is not found in the directory. So you can just write an error message here saying that file not found, okay, or something like please check again. So this is good for industrial practices. So make sure that whenever you're writing any kind of code, make sure it is according to industrial practices. So I will just run this. It says data has been loaded successfully. If the file is missing, it will say that data is not present. Okay, so loading data according to industrial standards. Okay, yes. Now once you have loaded the data, obviously now your data has been loaded. Now you can just simply print the data frame using the df.head. So a lot of people just like to write print df head, but I will tell you what is the difference between print and df.head. So print df.head is going to give you the data frame in the form of a string format. So now you can see here the table is not complete, right? It's just breaking off. It is giving you an escape character because it treats it like a string. So if you don't want to treat it like a string, you can simply print df.head, or you can simply print df also. Okay, so it's up to you what you want to do, but df will give you the values from 0 to the ending value, and the middle values will be it will be escaped. Okay, so if you want to just print the initial 10 values, you can give this particular command. I mean, not a command, you would say it is a syntax, which is df.head 10, which will print the first 10 values of your data frame. So if you just run this, you will be able to see that we have the first 10 values of the data frame, which is ready, right? Yes. Now moving further. Now we will start with our data inspection part. Okay, so the next step is where you start inspecting the data. Now what does inspecting the data mean? We have already discussed this, correct? What is data inspection? And one more term is nothing but data profiling. Okay, now data inspection and data profiling is nothing but checking the values that we have in our data frame. Okay, so just to check whether our data frame is good, or is it is it messed up? Is there some values that are not present? Is there any junk value? All of that. Okay, so all of that I will be we will be able to check that through this data inspection step. So data loading part is done. Now proceeding with the data inspection part. Just let me admit to people. Yes. Okay, so proceeding further with the data inspection. So first thing is we will learn how to check the shape of the data. The shape is nothing but the total rows and the columns that are present in the data set. So you can just write print, and here I'll be using the format option. Okay, so the format specifier will be not format specifier, format option will help me to print the entire thing inside a single print statement. So I will just write this and I will write df.shape. So yeah, if I run this, I'll be able to see that there are 1599 rows and 12 columns present. So these are nothing but rows and columns present in my data set. Okay, or here if you, instead of writing data set, you can write data frame. Yeah, we'll keep it data set. Doesn't matter. Okay. So this is the first thing that we check. The second thing that we can check is we can check the column names that are present. So sometimes what happens is maybe you saw the data frame and data set and you're like, okay, all the columns are present, but you just want to verify whether all the column names present are according to what I require. So what you can do is you can write print, you can just write a statement called columns. Okay, now we will try to print the columns that are present. So df dot columns. If you just write df dot columns, okay, what will happen is basically it will give you the index and it will give you all the values, I mean all the values of the column names. But if you want to just have, you don't want any kind of confusion like looking at index, all of this, you can just do one thing. You can print it as a list format. So what will this do is basically it will just give you a clean list of all the values present. No, nothing extra, nothing extra like index, and all of those things, right? So this is how you can print the column names to check whether the column names that you require are present in the dataset or not. Sometimes what happens is when you look at the dataset in the CSV file, you think that okay, everything is present, right? But sometimes what happens is some data might not be present inside that. So that is the reason why we need to check always if there is a column name that is extra or if there is a column name that we don't require, or all the column names that we require are present or not. So that is how you can check the column names. Then you can check the data types and the information about them. You can check the information that is present. You can get some statistics also, right? So how will you get the data info? So you can just print here data info, okay, and you can simply write here df.info. Very simple, okay, very simple. df.info is going to give you the entire information of the dataset. So here if you see data info, it is going to say class. What is the class? Class is pandas frame, which is nothing but data frame. So it is giving you the class of the data frame. What is the class of the data frame? It is pandas data frame. Then it gives you the range of entries. So it gives you that there are 1599 entries and the values are from indexes from 0 to 1598. Then you will see all the different columns that are present. So you'll see fixed acidity, volatile acidity, all the 12 columns that are present. Then you will see all the values that are present here. Now, our main observation from this info is that we will be able to identify how many missing values are present in each column, or each column. Now in the first column you will see 1599, which is equal to the entries that are present. But now if you go down and check, I think everything is, yeah, except for the sulfates column, everything else has complete values, which means that in the sulfate column we have some values that are missing. Okay, now when you go back to the data set that we have here, okay, now you will see that the sulfate values is a number, right? It's not a categorical value. So when it's not a categorical value, you have the freedom to like basically choose between three different statistical methods. One is median, one is mode, one is mean. So these are the three different things that you can go with. Now if I take the mean of the data set, okay, mean of all the sulfate values, and try to fill all the values with the mean, would it be fine? Or do you think I should select the mode, or should I select the median? What do you think? What do you think should I do? Should I fill the values with the mean value? Should I fill it with the median value? Should I fill it with the mode value? And why do you think it is better according to you? Just tell me this much. Yes. Yes, guys. What do you think should be you know, the value that we should choose? Should we choose the median? Should we choose the mode? Should we choose the mean? Okay, Gautam says mean. Okay, so I will tell you one thing. that whenever you don't have okay, we'll balance the data set. Okay, so I'll tell you guys one thing. Okay, so how to choose between different values. So how to choose between mean, median, and mode. Now, when you have categorical values, right? When you have categorical values, always remember that 99% of the cases you choose mode. Okay, why do you choose mode? Because the thing is that mode can give you a better insight than the mean and median, because mean and median is usually used for what, for numerical values, right? But in mode what happens is you can simply get the most number of repeated values and you can give that value to the categorical value. So there you don't have any numerical value, right? So it is very rare for numerical values to use mode. Now, the two choices are mean and median. Now, how do you choose mean? How do you choose median? Now, if the data is symmetric, okay, now if the data is symmetric, so to understand if the data is symmetric or not, obviously you will have to look at the data set, right? There is no other choice that you have. Right? Now, to understand if if the data is symmetric, you will look at the data set and you will find out, okay, most of these values are giving me, close to average ish values. Okay, so what you can do is you can take the mean of all the values, you can calculate the mean, and then you will find out, okay, this mean value is closer to a lot of different values in the data set. Then you are correct to assume that it is mean. So mean has to be the proper assumption. Now here, since we don't want to do all of that, because we are not dealing in with marks of a student, or we are not dealing in with sales of a product, right? This is more related to a quantity. So whenever it is related to quantity, okay, whenever you are unsure of it, always make sure that you are choosing median. Okay, always make sure to be on the safer side, choose median. If you're unsure about it, just choose median and then fill the values. So that is exactly what we'll be doing. So remember this rule. First one is mode. Mode is very rare for numerical values, so make sure that you will never use mode for such cases. Okay, so I will write it down here. How to choose what value, no, how to choose what method to use for filling missing values. Okay, first one is mode. So it is very rare for numerical values, therefore you will not choose mode, you will always go for categorical values in case of mode. If you want to select median, so when are you going to select median? Only when you are unsure, that the data set is symmetrical in nature. Okay, and mean is when the data set is symmetric and the mean value is closer to the rest of the values. So these are the cases when you will choose between mean, median, and mode. And this is very important to understand because it is an important topic. Right? So if you understand this much, you'll be able to make sure that you can choose all of it better. Okay, so it's not working. I'll just write 1, 2, and 3. Okay, yes. Now, once we are done with the inspection part, now you understand how do we exactly do that. Yeah, one more thing that I missed out is the describe method. So there's another method, okay, which allows you to give the statistics. So statistical information. How do you get that? By using, so I'll write statistical info. Okay, and it is basically nothing but df.describe. Yes, so if you describe it, see, you will be able to see the count. So you'll be able to see the count of all the columns that are present. Then you will be able to see the mean values of all the columns. Yes, so here you can see that you have the mean for all the columns that you have here. Then the standard deviation is there, the minimum value, the maximum value, and 25%, 50%, and 75% of the distribution of all the values. Okay, so these values will be will be helpful when we are trying to do some data analysis, when we are trying to do exploratory data analysis. Okay, that is also something that we will explore later on, but not now, because once we finish the ML part, then it'll be easier for us to move on and uh, make sure that we study about different other different things as well. Okay, so yeah, so this is about the data inspection and the profiling method. Now coming to the part where you detect the missing value. So now we know, right? Now we know that there is a missing value in sulfate. Now what if you don't know that there is a missing value in sulfate? Let's say you did not just see that. Let's say you did not see that because there are like maybe 25, 30 columns, and you're not aware that okay, maybe there's every data. I mean every column has the proper number of values, and maybe you missed out on something. So now what you can do is, instead of relying on that method, you can write your own logic for detecting the missing values present in your data frame. Now how will you do that? Very simple. Okay, this method will work for any kind of data set. You use any kind of data set, especially numerical ones, it will work with anything. Okay, so this is a kind of you could say it's like a standard uh, formula, or you could say it's a standard syntax or a standard function, okay, that we can write for detecting the missing values, right? So we will just write here missing value detection. So it's like a trick, it's like a trick that you can follow always. So okay, so here we are going to first count the missing values per column. So count missing values per column. Okay, and here I will just write missing counts is equal to, so I'm just giving a variable name called missing counts. I'm going to give df dot is null dot sum. Now what this will do, it will find the is null values. So is null is a function, is a boolean function, which will find whether the dataset has has a null value or not for each column. Okay, so this is not for each column, this is only for a general dataset. So if I just write this, and if I write print missing counts, okay, it is going to give me per column all the missing values. Okay, now what if you want something more, you want the whole summary for the missing values that are present inside the data frame. So what you can do is, rather than just writing a very simple equation, I mean very simple syntax or very simple code snippet, what you can do is you can calculate the percentage of all the missing values also. So this is helpful for when you do exploratory data analysis. Okay, but we haven't come to that step yet. So this is the reason why I'm discussing it now, so that later on it will be very easy for you to understand. Okay, so what I'll do is I'll create a value called as missing PCD, which is nothing but missing percentage, and I will just write missing counts divide by the length of the data frame into 100. That is nothing but percentage, right? So now why have I done this? So if I print here, if I print missing percentage, so you'll see here yeah, you'll see here that all the percentages of the values are shown if it is missing or not. So here in sulfates column, you will see that 1.31% of the data set is missing from the entire data set. So basically 98.7 is present, and the rest part of it is missing. So this is also a place where exploratory data analysis will be very helpful in these scenarios. It will be helpful for exploratory data analysis in a lot of scenarios. Okay, then you can write you can create a data frame for this missing columns. So you can do pd dot, so if you want to create a data frame, you just have to write pd dot data frame. Okay, and here I will write missing count. This will be my column name, and this column name will tell me the missing counts. Okay, then I will have a missing percentage column, and then I will mention the missing percentages. Okay, and I will not display this yet. I will just write print missing values summary. display. Okay, so the display is a function which allows you to give you a representation of all the objects in Python. Okay, so if you write here missing df, and if I write missing df again, I'll just give the missing count. Okay, and I will just write here greater than 0. Okay, once I do this, I'll be able to see that I have the missing value summary, and whenever the missing count is greater than 0, it is going to display all the columns with the greater value. So it means that that particular value is missing from the chart and from the data frame. Okay, now coming to the part where, let's say you would have no missing values. Let's say you don't have any missing values. Okay, you can just write a very simple logic. Okay, and you can say that if the missing df, and out of this the missing count dot sum is double equal to 0. Okay, just print no missing values detected. Okay, so basically it means that if there is no missing value present, it is going to print this. Okay, so again, this is only for making sure that you are adapted to the industrial standard. So in industrial standards, according to industrial methodologies, these are some kind of steps that you should follow in a professional manner. Okay, so I'm teaching about professionalism also here, along with how you have to perform all of these different steps, because I've also done internships before on ML for different companies, and I have handled different clients for ML as well, and they expect every kind of professionalism, especially when they're working on a industrial project. So make sure that you follow this industrial standard of maintaining all the different steps individually. Okay, so this will give you a better control over everything. Now whenever you want to go back to something, you will remember, okay, I have already written a logic for it. So in case of this, if I just write a logic saying missing counts df.null sum printed, yes, I'll give the same result, but I'm going to get the results for all the different values which are also not missing, right? But I just want the missing count for the values that are missing, right? So that I don't have any kind of confusion in the future later on. So this is the reason why I have specifically emphasized on this kind of method, because it allows you to even in the future do some kind of exploratory data analysis based on these values that you've detected. Okay, so make sure that you follow this kind of industrial standard whenever you are starting to build your ML model. Okay, yes, so now let's move on to how to handle this missing values. So as I told you, we'll be focusing on filling these values using median. Okay, so for numeric columns, as I told you, if you're not sure about it, we are just going to fill it with the median value. Okay, unless and until you're very sure that okay, mean is the perfect way to go, yes, please go with mean. If you're not sure, just go with median. It will not make a lot of difference with that. So here I will just create a value called as numeric columns, and I will write df dot select data types. Okay, so why have I written this select data type function is because I want to select the particular data type of the missing value, which means that if it is a number, then I'll be making sure that okay, this is a particular number, so I am good to go. And what if it is not a number? Right? There might be some mistake that might be done, because median values cannot be used for a non-numerical value, right? So to make sure that it is a proper number, all the values are a number, we are just making sure that it has this parameter called include np number, which means that it will tell okay, the data set which we have, that particular column which has the missing value is of the type number or data or integer or float. Okay, and then I'll write dot columns because I am accessing that particular column. Now I'll write a logic. Okay, this is also for industrial standard. You can simply write a very simple line saying fill missing value, then df dot fill na df column, and you can write the column name. That's it. This will literally fill your column. But again, this is because I want you to follow the industrial standards, because It will give you more flexibility always. Okay, so make sure that it is being followed. So I will write for columns in numerical columns. So I'm writing a for loop. Why? Because I'll be able to get the individual columns from these number of columns inside the data frame, right? Inside my data frame, I'm going to select the data types which include the number only where from the columns. Okay, so I'm going to select the columns from the data frame, select the data types only where the data type belongs to a number. Remember this. Okay, since we are only filling it for the numerical values, make sure you are filtering out the numerical values only, because there might be categorical values also present, right? So since in our current data set we don't have any categorical values, we're not focusing on that part. We'll focus mainly on numerical. So we'll see even how we can do it for categorical values also. Okay, so I'll write here if df, and I will write the column. So if df call, that is column, is null dot sum, right? What is it? Is it greater than 0? If it is greater than 0, what should I do? I should fill it, right? So what will I do? I will just write df column is equal to df column dot fill na, and inside this I'm going to write df column dot what? Dot the median function, because I'm going to fill it with the median values. Simple, right? So this logic is going to save you hours of time, or you could say minutes also. If you're talking about a very complex data set, definitely it'll save you hours of time. But if you're talking about a simple data set, yes, it'll save you a lot of minutes doing entire handling missing values. Remember, if you do it singular, like if you do only for one particular, since we have only one particular column which has a missing value, here you can simply do it in an instant. You can just write numeric columns or fill numerical values is equal to df, put the sulfates column dot fill na dot median. Simple, one single line, done. But what if your data set has more than 4, 5, 6, maybe 7 values? Are you going to write it down individually? Of course not, right? So this is the best way to do it. It will detect automatically whether the number is present, and it was going to fill it automatically. So this is going to save you a lot of minutes writing extra unnecessary code. So once you do this, then you can simply write down here print, and you can write post handling info, right? So once you do this, and I will write df.info, we should be able to see that all the values have been filled. So you can see here sulfate has been filled. So for example, if your sulfur dioxide, your chlorides, your residual sugar all had missing values, this one logic will fill all of them together. Okay, so make sure that you follow this again, because this is a good practice industrial wise also, because it will save you a lot of time. Okay, yes, now we will go further with trying to fix the data types. Now here we don't have any fix to do. Okay, here we don't have any fix to do. So what we will do is we will keep this for another session. Okay, we'll keep data type fixes for another section. Now we will come with data cleaning part. So let's move on with data cleaning and logical rules. So how to apply logical rules and how to clean the data is what we are going to see now. Okay, so to clean the data now, we need to see there might be some kind of duplicate rows present, or maybe there might be some duplicate values that are there in the rows, correct? So to clean those values, to clean duplicate values, because duplicate values can play a very major role in ruining the performance of your model. So you have to make sure that you are going to remove those duplicate rows. Now to check first if there are duplicate rows, we will first write the logic for that. So remove duplicate rows. Okay, and while removing duplicate rows, the first thing is you will find the initial length of the data frame. So why are we doing this? Why are we finding the initial length? Because we need to know, right, how many values initially are present in the data frame. Then we will check for duplicate values. So you will write df dot drop duplicates. Okay, and now we will write here print f rows dropped So only the duplicate values will be dropped. Okay, duplicates. And this is this is an automatic logic to detect whether the uh, rows have duplicate values or not. So minus length of the data frame, or yeah, length of the, sorry, TF, length of data frame. Okay, so if you do this, you'll be seeing that the count of the values that are dropped. So what is the initial length? The initial length might be something, and you will be able to see the actual length of the data frame. So what this is the initial length. Okay, and initial length will be calculated after you drop the values, after you drop the duplicate values. Then it will be subtracted from the actual length of the data frame. Then you will find out that these are the total number of duplicate values present. So we are subtracting the length of the data frame with the initial length after the duplicate values have been dropped. Okay, now what we'll do is we will write a logic to reset the index after row drops. Now why are we doing this again, guys? We are resetting the index to make sure that once we have dropped the columns, we don't follow the same index. Now for example, check this data set. Okay, check this data set. We have the index 0 1 2 3 4 5 till 9, correct? Now let's say here you have dropped the 8th value, you have dropped the 5th value. Now instead of having the data set predict that okay, the values have been dropped, so what we can do is we can write 0 1 2 3 4 6 7 9, because 8 and 5 have been dropped, correct? So to avoid that, because sometimes the index might also be a feature, it might be a helpful thing that users might developers or ML engineers might focus on. So to make sure that the index is not broken, we are just going to reset the index and make sure the index is fixed. Okay, so we'll just write tf dot reset index, drop is equal to true. So this drop is equal to true checks whether whether the rows have been dropped or not. If the rows have been dropped, it will just reset the index. Simple. Okay. Now coming to the business logic. Business logic. Now, what is this business logic that we are going to talk about? Okay, the business logic is that, as I told you, we are going to check whether the quality of the wine is good or bad. Correct. Now, here from this mean, you can see that the quality uh, of the wine is between the range of 0 to 10, which gives a mean of 5.63, which means it says most of the quality of the most wines are approximately 5 to 6, right? So that is the quality of most of the red wines that are there in the data set. Now what if you want to um, write a logic which will detect the invalid quality? Okay, so let's say the quality of wine can only be between 0 and 10, and there is a value which says 11. Obviously that 11 value is wrong, correct? So you can write a business logic to check whether the quality of the wine is between the range 0 and 10. How will you do that? So let's have a look into it. So quality score should be between 0 and 10. Again, guys, this is not relevant to our current dataset because our current dataset has a good mean of 5.63, which means it says that most of our values are between 5, 6, 7, 8. Okay, so it is not above 10 or below 10, right? But we can't say for sure that, if just based on the mean, you can't say that okay, maybe there might be one value, right, that is out of the range of 0 and 10, right? So we have to check whether the business logic ensures that all the qualities are between 0 and 10, or qualities of all the wines are between 0 and 10. So how will we do that? So let's create a object or a variable called as invalid quality. And now what we will do is we will find the quality less than 0 and greater than 10. Okay, there might be some minus values also, like it could be some kind of junk value, right? So to check whether the quality is valid or not, we are going to first write a logic which says, is the quality less than 0 or the quality is less than 10, it means that it is an invalid quality. Now how to actually write a logic which says that we have some kind of invalid quality, or we have some kind of empty quality that is present. Maybe there are some empty values in the quality. So what we will do is we will just completely remove them. We will remove those values. So how do we do that? So let's write if not invalid quality, okay, dot empty. What are we going to do? We are going to remove them. So let's just write a print statement wherein we say that found these many values which are duplicate. So I'm going to write the length of invalid quality, okay, which means that these many invalid qualities are present in my data frame or in my data set, and I want to just say that these are my invalid quality records. Okay, so now I'm going to remove them. So removing them. Now how do we remove this? It is a very simple logic. That is nothing but if you are able to find the values, you will be able to remove them quite simple. So you can always go with this particular range, or you can write a simple equation for this saying that df is equal to df. Okay, for people who are not very good with Python, you can always go with a very simpler approach saying df quality less than 0 or quality greater than 10. So once you have done this, then you will understand that okay, these many values are empty or not good. No invalid quality records found, and all quality scores are in the range of 0 and 10. So if I run this, you will be able to see that rows drop duplicate, because we have already dropped the duplicate values before. So obviously now there are no duplicate values. So I'm saying, I mean, the logic that we wrote is saying that no invalid quantities are present. So we are not going to drop any invalid qualities because we don't have any invalid quality left. So I'll just remove this and I will just run this one. Okay, so this is how you can write a business logic for it. Now, coming to a place where you can feature engineer. Now comes the part which is important. Okay, and this is just, again, this is not based on any relevance with the data set for now. I'm saying for now because later on we have to build the ML model for this. So we will see the relevance later on, but this is only for you to understand how exactly you can do some feature engineering. Okay, let's say based on this data set, you have fixed acidity. Okay, you have volatile acidity. Okay, then you have citric acid. Okay, free sulfur dioxide, total sulfur. Okay, so one thing I can say here is that I can calculate the total acidity. How do I calculate the total acidity? Fixed acidity plus volatile acidity. So that will give me a new feature which is called as total acidity. So here in my data frame, I can create a separate column name saying total acidity. So what will this do? It will give me a final column name which has the total acidity, which adds both the volatile acidity and the fixed acidity. So again, this feature engineering part can help me to do some kind of exploratory data analysis or build an ML model which requires that feature. Okay, so this is one feature that I can find. What is the second feature that you guys can think of? I would like to hear it from you. So first one, an example I gave you, we can calculate the total acidity. So total acidity is nothing but volatile acidity plus fixed acidity. What is another feature you can think of based on this? Okay, Gautam, I just saw your question. Will data cleaning impact the... Yes, data cleaning will impact the model performance by a very huge margin. We will try it out later on, no worries. We will do this experimentation in class as well. So we will see... sorry. So we will see how exactly data cleaning helps us in, ensuring that the model's performance is good or bad. So we will try to do all of these kind of experimentations. We will look at different edge cases as well. Okay, so don't worry about that, Gautam. Yes, so right now my question is that one feature that we can engineer is total acidity. What about another feature? Let's just give me one more feature so that I can continue with that. Free sulfur and oh, very good, Nitish. Yes, that would be a good one. You're saying ratio, right? Ratio of sulfur dioxide. Yes, we can do that. Good one. So I was thinking I was thinking like the total acidity or something, based on the alcohol and the pH value. But yeah, but that was a good one that you gave me. Yes, free sulfur and total sulfur dioxide. So we can calculate the ratio of the sulfur dioxide present in our wines and our different wines. So let's try to do some feature engineering. So first one example, we will take it as total acidity. Okay, and the second example, we will take it as uh, ratio of sulfur dioxide. Sulfur dioxide. This is nothing but free divided by total. So this is going to be our formula. Very simple. We just have to apply this formula. So we'll write if fixed acidity, okay, in df dot columns. I think the value is correct, right? Fixed acidity. Okay, it's not underscore, right? It is space. Okay, sorry, not fixed acidity in dm columns. And what is this one? Volatile acidity. Yes. So and volatile acidity again in df dot columns. Okay, what are we going to do? We are going to write df total acidity is equal to fixed acidity plus volatile acidity. So this will give me the total acidity. Second, let's see if we want to find the we want to calculate the free sulfur dioxide per total sulfur dioxide. So again, the same thing, just like how we did it here. If free sulfur dioxide in columns and if total are there if it is present in the columns, then what we will do is, sometimes what happens is, let's say the total value is 0. Okay, now here comes the tricky part where you have to apply some kind of logic. What if the total value is 0? Obviously there will be division by 0 error, correct? So to avoid that, we will write a logic for avoiding division by 0 error, right? This could be a very simple thing. So I will just write here, so this new column name, I'll give sulfur dioxide ratio, and yeah, divide this by the total sulfur dioxide ratio, right? And I'm going to make sure this is not the logic. Okay, now what I'm going to do is I'm going to make sure that the total value is not going to be divided. I mean, the free sulfur value is not going to be divided with the actual value. Okay, so I'll just write here replace what? 0 comma nb dot nan. That's it. Very simple. What I've done here, instead of dividing it by 0, I have kept a null value. So what will happen is, if I divide it by null value, it is going to remain as null itself, right? So I don't have to basically do anything else. So if I just write over here, and then I can go ahead and fill the sulfur dioxide ratio. So let's say if I've replaced this by a null value, I can just simply go ahead and fill the sulfur dioxide ratio with the null value, I mean with a 0 value or an empty value. So sulfur dioxide ratio is equal to df sulfur dioxide ratio, okay, dot fill na. What am I going to fill with? A 0 value, because obviously this will throw me an error, right? 0 division will give me an error. So what I've done is, instead of giving me an error, it will replace this 0 with a null value, so that it will divide it, but it will not give it will give some junk value. So instead of giving a junk value, instead of giving a null value, I will just fill that null value with 0. So that ratio will be 0. Okay, so because it is an invalid function. Then finally, I will just write here, I will just validate feature distribution. Okay, and I'm just going to write df. So since we are going to write two column names here, so I have written two square brackets. So total acidity, comma, sulfur Okay, 1 second. Yeah, sulfur dioxide ratio, right? I'm going to print these two and I'm just going to write describe. Why have I described? So that I can get, okay, there's some kind of error here. Where is it? Total acidity. Oh, there's no underscore, sorry. Yeah. So once I do that, I'll be able to get the count of all the values that are there. Right? So it means that this shows that if you see here, the count is 1361. But what is the original count of our data frame? 1599. So you can see that how many values of sulfur, the free sulfur dioxide or acidity is having a null value. So that is the reason why all these values are being removed. Okay, so all the values that are not present in this will be basically removed because of the null values. So based on this, we'll be able to see that we have all the statistics that are required, right? So this is exactly about how you perform all of these steps, and all of these steps, minded guys, that everything is related to a industrial standard. Okay, so I whatever I'm discussing is based on the industrial standard. This is not your regular session that we're trying to do here, right? We are trying to do an internship, so that is the reason why I have kept everything in mind regarding the industrial standards. Okay, so let's stop it here today. Let's just take some time to process all of this. Try to have a look into this notebook. I will share you this notebook definitely, and we will further work on this notebook itself. So for quite some time, we will work on this notebook to make it a full-fledged ML model. So once we finish that ML model, then we will see an entire ML workflow that we will come across, and then we will discuss about different sorry before we see the entire ML workflow, we'll discuss about the different methods of ML. So today, this is it. This is about whatever we have learned till now, up till feature engineering. Then I think feature scaling is remaining, that we can try to do it tomorrow, along with the continuation of the rest of the theory that we have, okay, which are the types of ML and all of that. So yes, that's it for today, guys, and I hope you had a good session of understanding a lot of different things, how things work in an industrial grade, and I'm pretty sure this will help you a lot